So the first thing we do, besides copying this down correctly, which is super important, is then we're going to count how many of each element are on each side of the arrow. So underneath the arrow, I'm going to write each element I see. How many silicons are on the left of the arrow? There's no number after that, so it's assumed to be 1. How many silicons are on the right of the arrow? Again, there's no number after the SI, so that's assumed to be a 1. By the way, if you're not writing in a pencil, you should. I'm using an erasable pen, so I'm getting away with it. But make sure you're writing in something erasable. I've got pencils if you need them. How many chlorines are on the left side of the arrow? 4. How about on the right side? 1. How many hydrogens on the left side of the arrow? 2. How about on the right side? 5. There's 4 here and 1 here. So we have to find all the hydrogens when we add up hydrogens. And then how many oxygens on the left? 1. And how many oxygens on the right? 4. Now, this is the first practice problem for balancing we've done, where we've had an element in 2 different spots on the same side of the arrow. Step 3 told us that if that happens, save that element for last. You can balance any other element, but don't try to balance hydrogen because you wouldn't know where to add it. It's going to make it more complicated. So if you save that element for last, what will happen is it will naturally become balanced when you balance the other elements. So we can start by balancing silicon or chlorine or oxygen. Any of those are appropriate choices. So which element do you guys want to balance first? Chlorine, okay. So what number do we need to put here to make it so there's 4 chlorines on this side? Because there's 4 on the left, so we need 4 on the right. A 4. And that makes it so we have 4 hydrogens here plus 4 there. So our hydrogen number changes to 8. And our chlorine number changes to 4. Everybody with me so far? Good, we've balanced chlorine. Now the only other element left to balance, because we're going to save hydrogen till the end, is oxygen. There's 4 oxygens on the right side of the arrow. So what number do we have to put here to make 4 oxygens on the left? A 4. And that makes it so we have 8 hydrogens and 4 oxygens. And look at that. The hydrogens kind of balance themselves, right? Last step, step 4 of our notes from Tuesday, says to make sure that we are in the lowest possible ratio. Well, this is a 1, right? 1, 4, 1, 4. So can we divide those by anything to simplify? No. So that's our answer. We're going to do a few more of these together to practice the skills, and I'm going to have you practice them independently. All right. Let's do Na2CO3 plus HCl makes NaCl plus water plus carbon dioxide. Sort of a long one. So remember, underneath the arrow is where we're going to write all the elements we see. There's 5 elements this time. So you start counting up what's on each side. See if you can beat me to getting this equation balanced. I'm sitting here looking at my numbers thinking I need to balance hydrogen. It's the only, or sodium. Those are the only two that aren't balanced. And so if I want to balance hydrogen, I need to have two hydrogens on this side, so I put a 2 there. And that makes it so I have 2 hydrogens and 2 chlorines. And then I want to balance sodium, and if I put a 2 here, then I have 2 sodiums and 2 chlorines. And while that problem looked hard, I've now balanced it already. Any questions at all? If you follow the same steps every time, you kind of know what to do next, and eventually you'll get there. All right, let's do a third problem. And then the fourth one we're going to do together is going to be a bit of a challenge, but I believe in us. So we got KClO3 breaking into KClO4 and KCl. So notice I drew my elements shifted over because I want it to be under the arrow. So I'm always looking on the left side of the arrow and the right side of the arrow. So I draw those lines of elements so they're always under the arrow so I don't get confused about what I'm looking at. All right, how many potassiums do I have on the left side? How many on the right? 2. 1 here and 1 here. How many chlorines do I have on the left? How many on the right? 2 as well. I got a chlorine here and a chlorine here. So neither of those would be a good element to start trying to balance because they're found in more than one place. And then lastly, I've got oxygen. How many oxygens on this side? And how many over here? 4. So oxygen is the most obvious element to balance because potassium and chlorine are found in 2 different places on the same side, so they should stay till the end. But take a look at that. Here, oxygen comes in 3s, right? That's what the subscript says. Here, oxygen comes in 4s. So to balance oxygen, we need to use our math skills and say to ourselves, what is the least common multiple of 3 and 4? Jackson? 12. So we need to find a way to get 12 oxygens on each side. What number do I put here to get 12 oxygens? A 4. And that makes it so we have 4 Ks, 4 Cls, and 12 oxygens. And then we said we wanted 12 oxygens on both sides. So now what number do we put here to make 12 oxygens? A 3. So when you add it up, I've got 3 potassium here plus 1 over there. That's 4 potassiums. I've got 3 chlorines here plus 1 over here, 4 chlorines. And that gave me 12 oxygens. So we're balanced. Any questions? All right, this is what? Oh, can we reduce these? So we've got a 4, a 3, and a 1. So can that be simplified? No, it's always good to check for sure. All right. This next one is the type of problem where I might accidentally get out of control, but hopefully I'll rein myself in. So we've got aluminum plus HCl, that's hydrochloric acid, by the way, making AlCl3 plus H2. This one might look easy, but it's actually kind of tricky. But if we follow the steps, I believe in us. I did this as the first problem last period because I thought it was easy, but I was wrong. Is there any element that we should save till the end here that we can look for sure and know we should save till the end? Is hydrogen found in more than one place on each side? I see it once here and once here. So it would be okay to do. Each thing's only found once on each side, so there isn't really an obvious place of where to start. Obviously, well, here's the obvious. We don't start with aluminum, right? It's already balanced. So we can choose chlorine or hydrogen to start. What would you guys like to start with? Chlorine? All right. So we have 3 chlorines on this side. What number do we need to put here to have 3 chlorines? A 3. And that makes it so we have 3 hydrogens and 3 chlorines. Oh, so now we need more hydrogens on this side. So what number should we put here to make more hydrogens? Oh, you guys are smart. A 3, that gives us 6 hydrogens. So now we could go back over here. What number do we need to put here? That's why you need to have a pencil. We can change that 3 to whatever number we need it to be, and we're going to try a 6. And now we have to balance our chlorine. So what number do we need to put here to make 6 chlorines on that side? A 2. And that affects aluminum and chlorine. And then we put what here? A 2. So it didn't look that hard, but it kind of turned into a slightly complicated problem. But if you're following the steps, if you're writing how many of each element you have, you can keep organized and do what you need to do. Now, this is definitely a problem where we want to ask that question. Can we reduce these numbers? Is there anything, especially when there's numbers in all of them, you always want to check. Is there anything that these could all be divided by and still get a whole number? No, because we've got 2s and 3s. So we're good. That's balanced. So for the rest of the period, I want you to work on the back of Monday's worksheet. So Monday's worksheet that looked like this, that said how many atoms, has a back that says balance the equations. And they're not super hard ones because this is our first time practicing independently. But our assignment for the rest of the day is to work on these practice problems, and then you can check your answers. They're linked to the Zooms and other important links website. So that's what we're going to do for today. And then just to remind you, tomorrow and Monday, you guys are going to be watching a documentary and answering some questions about it on a Google Doc. Tuesday, I will be back and we will be doing more balancing practice. And then Thursday, we're going to do even more practice and then have our homework quiz on balancing equations. So there's still lots of practice between now and when we have our homework quiz on balancing. Yeah. What? Yeah, I've got a few extras and then people have to just look them up and do it on paper. So for my Zoomers at home, you guys are welcome to stay if you'd like, or you can just go work on this worksheet and check your answers on the link.